Hello, so now we're going to investigate a balanced binary tree problem. So we're given a binary tree, which is just a node with two subnodes or subtrees, right? Those could be none, meaning they're empty, or they could be other proper subtrees. So we could have 0, 1, or 2 subtrees, and then we're going to determine if the height of, this is just a definition of height balance. So it's a binary tree in which the left and the right subtrees of every node differ in height by no more than 1. So how we're going to do that is we're going to use recursion. But to first do that, we have to find what the height is. So I'm also going to do that recursively. So I'm going to have another function, and the self here was just because we're dealing with a class. That's how the code works. So it's going to take in the root, and if the root is none, then I can just return, it's going to be of height 0. Otherwise, I'm just going to recurse by getting the max of the height, I should call this height. I'm going to the max of the height of the left subtree and the height of the right subtree. Whoops, I just have to do self here because we're dealing with functions. So we're dealing with classes, and then I'm going to add 1 because we have to add ourselves, or else this will never increase. So now, all I have to do is my recursive statement is not, if root is none, then we just return true, because if we reach an empty one, we don't want it to ruin our proper values which aren't none. And then if the absolute value of the height of the left and the right, so height, self.height of root.left minus self.height of root.right, if that is less than or equal to 1, which is the definition here, no more than 1, and if that's true, we're not done yet, because we have to check that the keyword is every, so we have to check that both left and right are also balanced. So if self dot is balanced, if it's true for the left, it's also true for the right, then we can return true. Otherwise, we would just return false. And we could combine this into 1. In fact, I might just do that to illustrate. It would be a pretty big if statement. It's pretty ugly. But essentially, if one of these is not true, then we're just going to return false, and that will sort of propagate up. Otherwise, we're going to, whoops, yeah. Otherwise, we just return true. So let's see how that goes. That's done. Let's submit it, see how we go. And yeah, we're done. But there was this sort of inefficiency here. That's, we're doing recursion to find what the height is, but we're also doing recursion to find what the is-balanced is, which is kind of a waste. So what I want to try and do is I want to combine these into 2 to increase the efficiency, to lower the bigger notation. And how I'm going to do that is, you see, when we get the height, you can also sort of see if the subtrees below that are balanced themselves. We can sort of start from the bottom, go up a bit. If it's balanced, then we can go up again, returning the height. Or we can just return something that signifies it's not balanced. So how I'm going to do that, I'm going to get rid of this, and I don't need this anymore. How I'm going to do that is I'm going to use recursion, where I return the height if it's balanced, otherwise I return -1. -1, since obviously it's going to be nothing of height -1, unless it's not balanced. So I'm going to use a helper function. If root is none, I just return 0. I don't want to return -1 because we're always going to get to none, since there's going to be roots which have empty subtrees. So otherwise, I'm going to get left, and I'm going to get the helper. I'm going to use helper, which is a bad name, I guess. So I'm going to check the left, and if this has returns -1, then it means it's not balanced, so I just return -1, and that's what propagates up. Same thing with the right subtree, root.right. If right is -1, same thing, I just return -1. And now, so these are going to give the actual height now, since I've checked that they're -1, meaning it's not balanced. So now what I do is I just return, I have to check if it's balanced or not again. So that's going to be if the difference of left and right, so that's only equal to -1. That means it's cool. So if this is not true, return -1. Now here I just return the height. And the height is going to be the max of the left and the right plus 1. And now all I have to do is I have to properly write the is-balance function. So here, all I'm going to do is I'm going to check if it's -1. If it's -1, then it means somewhere it wasn't balanced. So I'm going to do if self.helper, self.helper, pass in root. If that returns -1, I just return false, otherwise it returns a proper number. It's height actually, so I just return true. Hopefully I haven't done anything too stupid, hopefully that works. Okay, that's working, and yeah, that's working. It did like quite a bit fast, although this runtime is dependent on your internet connection, so it's not too reliable. However, we have reduced the complexity by essentially combining each recursion into one. So it only visits each node once, whereas before it might visit multiple times. So yeah, that's it. Thank you.